In simple networking, if you are communicating with any two end PCs or something like sending messages to any two PCs, like uh, if you are in home and messaging your friend, then let it be your, this is PC1, this is your PC, and this is your PC, this is your friend PCs, right? So if we want to communicate with each other, then we need to have something like address. In OSI reference model, we need to have some address that are called layer 3 or layer 2 address. Okay, without layer 3 and layer 2 address, layer 3 address means IP address, and the layer 2 address is MAC address. Without these address, we cannot communicate with each other. So uh, there are source IP, right? Source IP, which is your IP, which is the IP which is used to send the data. So there is what? Destination IP, and another is source MAC, and another is destination MAC. So these are the four things that is required to communicate over the internet, right? So if in a simple scenario, um, I will be demonstrating you towards the ARP by using the ping tool, right? PING ping tool. So if we have the IP address 192.168.1.1 and 192.168.1.2. So these are the IP address assigned to the specific PCs. So this dot 2 is the IP address for PC2 and dot 1 is the IP address for PC1. Are you getting, guys? Please acknowledge. Hello?
Yes, go ahead, please.
Okay, thank you. So these are the respective IP address, right? So we are going to use ping command to demonstrate this scenario, right? So I will be using two PCs from the Cisco Packet Tracer. This is the Cisco Packet Tracer software which is used to emulate the real scenario of the networking, right? You don't need to buy the real PCs and real laptop to practice. So this is the best software product provided by Cisco. So you can use it and download it in your computer freely without paying anything. So this is the PC1 and here is the laptop. This is what? PC2. So I am going to assigning the IP address 192.168.1.1 IP address /24 value, which is the class C IP address, and same network 192.168.1.2/24 IP address in the PC2. So to assign, simple, you need to click over here in desktop, and here is the IP configuration channel, right? So just clicking here, you can assign the static IP address over this PC. It's very simple. So I will type this IP address 192.168.1.2, and here this is the subnet max for this PC. So at least we need to know these things, assigning the IP address in the Cisco Packet Tracer to the PC. Same thing goes over here. So desktop IP configuration 192.168.1.2 IP address. So this is the address is already used in the network. It means it is assigned to this. It may be. So 1.2 is mistakenly assigned over here. So let me correct this. So 192.168.1.2. So this is the what? IP address assigned to the PC. So we need to change the MAC address to get recognized easily. Okay. So in Cisco Packet Tracer, we can change the MAC to practice. Okay. So this is one of the best thing. So 00000000A. So I am writing 48 bit. So each digit is a hexadecimal. So there are 12 hexadecimal values. So 12 hexadecimal value means 48 bit, which is a MAC address. So you can have this information in networking, basic information. IP address is 32-bit address and MAC address is 48-bit address, which is MAC address is layer 2 address. So IP address is layer 3 address. So these are the things. I just reconfigured the MAC address over PC1, and in the PC2 we can go config and fast Ethernet. In the NIC network interface card, the MAC address is assigned, right? So I am changing the MAC address over here, 000B. So these are the respective MAC address assigned to the PC. By default, we don't need to assign the MAC address in our laptop or computer, right? Because manufacturer already provided a MAC address to our network interface card. So in our computer, how can we check the MAC address? Oh, okay, sir. Yes. So in our computer, how can we see the IP address and the MAC address assigned to our personal computer? So there is a simple command. In Windows operating system, you can type ipcon fig ipconfig/all. It will address or shows the MAC address as well as the IP address assigned to the respective interface, right? So I have a wireless network interface card. So in this, you can easily see the IP version for address here, 192.168.1.77, and the physical address, the MAC address is also known as what? The physical address. So this is my MAC address assigned to my computer by manufacturer. So I don't need to change this. So I just applied here to make you clear, understand, right? So 00A, and this is the MAC address for respective PCs. So I am using the in scenario 1. I am using the ping toolkit, right? Ping is something like a tool by which you can check the reachability. So in every default computer in Linux machine as well as Windows machine or in packet tracer, you can use the ping utility, right? So ping is used to check the reachability in the network, right? So you can check either the device is connected over here and can send a message or not. So we are going to look at like this. So for ping, we need source IP, destination IP, source MAC, and destination MAC. So for communicating, we need these 4 address, right? Source IP, destination IP, source MAC, destination MAC. So if we type the ping command over here, ping 192.168.1.2. So if we type the ping command over PC1, then what is the result? The source IP. This is the source IP, right? The PC itself knows its IP address. So source IP is fulfilled over this field, 192.168.1.2. And what is the destination IP? We have provided the destination IP, so it is the destination IP. So it is also fulfilled. 1.2 is the destination IP and 1.1 is the source IP. And what is the MAC address of the source IP, right? So we are pinging from PC1. So itself we are pinging from PC1. So by default, the PC1 knows own MAC address, right? So we can write its MAC address 0000 and 0000 and 000A. So this is the source MAC address. But the real case is, what about the destination MAC address? The PC1 does not know the destination MAC address of PC2. We have provided the IP address of destination IP, but we don't provide the destination MAC address, right? So this is the actual need of the ARP. So the need of ARP is to resolve this destination MAC address that is unknown in the destination. So MAC address, which is a destination MAC address, by using the ARP technology or address resolution protocol, we can resolve or we can know this MAC address. So how this scenario works, let me explain by step. So we will be doing something like theoretical concept first and practical concept. Okay, so when how does ping works, you need to know how does ping works and how does ARP request and ARP reply works, right? So ping is successful only if two PCs, the source PC will send what? ICMP request message, and if the destination PC replies back ICMP reply, then the ping is successful. But the ICMP request and ICMP reply needs what? Source IP, destination IP, source MAC, destination MAC. So the first packet will drop so that the PC creates a ARP packet. So what? The PC creates the ARP packet. So I will be demonstrating you the ARP message. So first of all, ARP working. So ARP working is something like this. If we have two PCs, then ARP will request ARP request. So ARP will, the PC1 will send the ARP request to the PC2, and the PC2 will reply its own MAC address. The PC2 will reply its own MAC address towards the PC1 so that PC1 and 2 can communicate with each other. So let me demonstrate you with the simulation mode. There is the simulation mode, right? So I am using the ping tool in the PC1 as I have already said. So go to the command prompt of PC1. So simple, you can click here, PC1, click over here and go to the command prompt. There are more utilities in the packet tracer. So we need what? Command prompt. So in command prompt, simple, you can type the command ping 192.168.1.2. What does it represent? It represents that check the reachability towards the 1.2 IP address. So this command represents check the reachability towards the 1.2 192. This IP address, right? Is this IP address is connected or can communicate with PC1 or not? So let us press the enter key. See here. So there are two packets created over the PC1. When I enter, there are two packets created over here. So one packet is what? ARP, address resolution protocol, and what? Another packet is ICMP. So I would like to inform you that or question you that which packet will go forward, ICMP or ARP? The PC1 does not know the MAC address of PC2, either the ARP or ICMP. Please, anyone reply if you understood.
Yes, correct.
ICMP packet or ARP packet will go first. Hello? Routing.
Hello, sir. How are you?
Yes, bro, I am fine.
It's very nice, son.
Yeah, would you like to answer?
Regard which one?
I am asking a question, little bit simple question. There are two packets created here, right? In this topology, PC1 want to communicate with PC2, and there are two packets, ARP packet and ICMP packet. In the ARP table, the PC1 table, the PC1 does not know the MAC address of this. So from these two packets, the ARP or ICMP, which packet will move towards the PC2 first? That is the question.
Oh, my answer is ARP goes first.
Yeah, definitely. The answer is correct. Because the PC1 does not know the MAC address, so it will drop the ICMP packet and move forward the ARP packet. So we can click here, simple. It's like a game. See which packet goes here. Let me stop. ARP packet comes first.
Ice bro,
Yes, bro.
your screen share is stuck.
Oh, oh. Is it
Okay, sir. I will check my internet.
okay? Okay, thank you.
Okay, Vijay sir, I will check my internet connection. Let's start. Mr. Ice sir, let's
Okay,
start.
thank you. And the PC1 sends the ARP message first towards the PC2. So this is why, because PC1 does not know the MAC address. Before ICMP, why ARP resolution works? Because PC1 does not know the MAC address of PC2. So to resolve this ARP message goes over here. So let's start this PC reply. So this is what the PC reply. Here again the ARP PC2 sends the ARP reply towards the PC1. PC2 reply the PC1. Okay, and then next which packet comes? ICMP packet, because we are pinging from PC1 to PC2. So the real use is to send the ICMP packet, right? So before ICMP packet, the ARP packet is sent over here, and the MAC address is learned by the PC1. So we can check the MAC address is learned by the PC1 or not. What is the MAC address of PC2? We can simple go to the command prompt. So let me finish this ping. So I already started ping. So let me finish by next. It's a simulation mode. So let me come into the real mode. So we can see the ping is successful, right? So we can check the ARP table by using a simple command in PC, right? ARP/A. So this is the command to see the MAC address learned or that is available in the ARP table. So in which table the ARP or MAC address learned by the PC is stored, that is the ARP table, right? So to see the ARP table, there is a simple command ARP/A. So this is the command that is used to see the result MAC address. So you need to see these things. IP address, for this IP address, the MAC address is this 00000000B. So this is the 48-bit MAC address, and the type of the MAC address learned is dynamic. So how it is learned? We didn't entry or just manually configure the MAC address in the ARP table, right? We don't. It is dynamically learned the MAC address. So this type is what? Dynamic. So this is the command which is used to see the ARP table. So if we want to remove or clear all the MAC address entities in the ARP table, then there is a simple command ARP/D. So the MAC address are cleared. If you want to see, just click the same command, no ARP entities found. So in simple, our computer, right? So there are something command change, right? In packet tracer, some commands works, and to do the same task in Windows or Linux, another command is used. So ARP/A. So same command is used over here. ARP/A. You can view your ARP entities or MAC address learned by your PCs. So this is the command, and to remove ARP/D. So it says the ARP entry deletion failed. So to delete all the ARP, we can type ARP/D asterisk. So asterisk means select all. So we can type enter. ARP entry deletion failed. So I think this is due to the administration mode, right? So we need to open the command prompt giving it's a privilege as an administrator, so that we can delete the ARP. So ARP/A will display all the MAC address learned by the PC, and ARP/D asterisk will delete. Yes, it works. So if you want to see again something like this, there are more MAC address, but there are less. Why? So this is the static MAC address. So this is something like the most useful address which cannot be removed by default. So this is my default gateway, so this cannot be removed. So there are some limitation over here, right? But all other MAC address are removed using this command, which ARP -D asterisk. Asterisk means select all. So let me accept other users also. So these are something like Cisco packet tracer, but I'm going to show you in the live capturing packet, right? So a new private window. I'm opening my PNet lab or EBENG, okay? 192.168.241.128. So this is something like a complex environment where you can practice your networking, cybersecurity, or many things. So I am creating a lab over here, name ARP PRACTICL ARP practical. So add. So I will delete this logo. So I am adding something like a router, right? I will be using router as a PC. So I will be using two router as a PC. PC is the name, and we can select the icon as well. This is something like a strong software you can download in your computer or setup to practice, right? PC. I will be selecting this Mac PC as an icon. And then I will be save these things. So you can really practice in a live scenario like this. So let me connect this to PC with the fast Ethernet 0/0 and 0/0. The FA 0/0 means fast Ethernet. You can have this information about the links in the networking basic terms, right? In Cisco N plus or CompTIA N plus or Cisco CCNA, CCNP, write these things. So these are the out of the topic. So I will be starting these two PCs over clicking here. The real concern is to understand the ARP and to capture the ARP table or ARP packet. What is inside the ARP, right? Because if we know what is inside the ARP table, then we can hack or we can spoof the ARP. How does it works? We need to know. And the interview question is something like most asked interview question is something like from the ARP, and also in the examination also. So I am using router as a PC. So these are something like the Cisco information showing me by default. So let me configure the IP address, right? First of all, to demonstrate, I have already configured the IP address in Cisco Packet Tracer. It's same, I am going to configure IP address over here. So to configure the IP address over here, I am using the IP address 192.168.1.1 and 192.168.1.2. So these are the respective IP address that I am assigning to these PCs. So in PC2, I'm going to configure IP address 192.168.1.2 255.255.255/.0. So this is the class C IP address. So this is the subnet mask for default class C IP address, and this is the IP address. So this is simple command that is used to assign the IP address. But first of all, we need to go into the interface. In which interface we are going to assign the IP address? INTER FAC interface, FAST fast Ethernet 0/0. So over here we are going to assign this IP address, right? So node sort. So you don't need to memorize this command. This is the simple command used to assign the IP address over the switch, a switch or router. Enable config terminal interface fast Ethernet 0/0 IP address 190.168.1.1 255.255.255 and no sort. So this is the simple command used to assign the IP address over the interface. So I am doing something like capturing the packet over here, right? So I will start the Wireshark over this fast Ethernet 0/0 link. So just I am clicking over here and starting the capture. So my Wireshark is started, and this is something like by default message that is used to deliver over here and there in the network because of its own use, right? Already by default these protocols works in this router, so there are some packets, but our real concern is to view the ARP packet, right? So I will be pinging from PC1 to PC2. I will be pinging from PC1 to PC2. So that the MAC address of PC2 will be resolved by the PC1 so that they can communicate in ICMP packet with success.
Hey, Ayush,
Yes, please.
before pinging, do a show ARP so you can show them that the ARP table is empty.
In this topology, right?
Yeah, right. So they can see
Okay.
the ARP table is empty, and then after you ping, you'll see the ARP entry over there.
So this is the ARP table, right? So in the PC2, the 192.168.1.2 is the IP address of PC2. So PC2 knows its own IP address and MAC address. So this is the by default MAC address and IP address of the PC2 own MAC address, right? Are you clear? So there are no any entries about PC1. Okay, we can wait. Okay. Just I I'm making something like simple, so because the people are unknown about what is routers. Okay, let me change something like the host name of router so that it will be clear. Host name and PC1, so it will be more clear to you guys. So this is the show command that I entered, and the MAC address in this PC is look like this. So 1.2 is the IP address of its own, and as is there is no limit in the aging time. This MAC address will not be cleared by default, right? Because its own MAC address and its own IP address of its host machine. And ARPA is the protocol that is used by the Ethernet technology. So this is using Ethernet technology. We need to understand like this. And there is no any entities in the ARP table, right? And let me check if there is entities or any MAC address in the PC1 or not. So simple, we can type show ARP command. So this is the IP address of PC1, and this is own MAC address, right? There is no any MAC address of PC2. Are you clear, guys? Please acknowledge.
Yeah, please proceed. I'm following.
Okay, thank you. So I am capturing the packet in the PC1, right? The link is the Ethernet 0/0 of PC1 is captured in Wireshark. So I am using the ping command in PC1 to check the reachability towards the PC2 so that we can see the ARP message. So simple ping 192.168.1.2. I will be pressing the enter key. So simple, I would like to make you understand this is the ping command is the utility that is used to check the reachability between two end host. Okay, so the IP address that is entered here is the destination IP address. So let me press enter. So the ICMP success rate 80% because the first packet is dropped due to the ARP, because when it is ICMP packet is prepared, it does not know the destination MAC address, so ARP packet will go first. So let me go towards the Wireshark and see. This is the ARP message, right? This is the ARP message. So let me filter ARP. We can filter simple. So these are something like the ARP message. So you can see here, frame Ethernet address resolution protocol. So over the Ethernet header, so this is what ARP packet. So it is encapsulated in the Ethernet header and Ethernet trailer, right? Ethernet header and Ethernet trailer. So it is the important point. There is no any IP packet. So we need to understand this is the layer 3 technology, or something people say 2.5 technology or 2.5 layer, but it is not, because there is no any 2.5. There are 1, 2, 3, 4, 5, 6, 7 layers in OSI reference model, right? So there is no any 2.5 technology. So if anyone asks you which layer is the ARP working on, and you need to reply the ARP is a layer 3 protocol. So ARP is encapsulated over the Ethernet, right? So let's start from the Ethernet section. So the source MAC address is what? The MAC address of PC1. This is the MAC address of PC1, and in the destination there is all F, right? So it means that the Ethernet packet, this is ARP and this is Ethernet trailer and Ethernet header, right? So in here, in the layer 2 address Ethernet header, there are the fields, that is preamble, right? Start frame delimiter, source MAC, destination MAC, like this. So in the source MAC and destination MAC, source MAC has the MAC address of PC1 and destination MAC has F. It means the ARP packet created here is a broadcast packet, right? It is what? The broadcast packet. So this packet will send over all networks in a single network, right? In that network, it will broadcast this packet. So the destination MAC address means this. Let me clear. So I would like to make you understand over here. If we have the PC3 and PC4, we cannot connect like this. If we have switch over here and connected more two PCs, PC3 and PC4, like this, okay? So the ARP packet will broadcast over here, here, and here, okay? This means all FF means broadcast packet. So you can easily understand this. So let's go into the Wireshark and let's start to see what inside the ARP packet. So this is the ARP. So we need to understand these things. This is the packet where the fields are the ARP. So these are the information that is inside the ARP packet depth. ARP. So this is the most important thing you need to understand. Ethernet header, Ethernet trailer. So what is the difference between the FFF and 000? You need to understand this, okay? So we are going to learn these things. Into the ARP packet, these information are available. So we are going to study these step by step. So hardware type. So what does hardware type means? Hardware type means which technology it is using? Ethernet technology. Which hardware technology is using? Ethernet technology. So something like in hardware technology, HARDWARE, hardware technology, there are something like different technologies over here. Some are Ethernet and token ring, like this, okay? Token ring is obsolete, no more in use, but Ethernet are something like used in recent technology. All the networking devices and networking components use Ethernet technology. So this means This is the Ethernet technology. And what is protocol type? Protocol type means it is using IP version 4. We configured 192.168.1.2, 1.1 and 1.2, right? So these IP addresses are layer 3 IP version 4 IP address, because in IP version there are two types of version of IP address, IP version 4 and IP version 6. So it is the 32-bit address. So this is what IP version 4 address. It clarifies that there is the use of IP version 4. And what does it represent? It is the hex value, right? It is the hex value. So it means 0800 means it is the IP version 4. So hex value represents this is the IP version 4. So we also did this, we also did this. And what is the hardware size? Something like this is the size of the MAC address. How many bytes of the MAC address is there? There is 48 bits, right? 48 bit of MAC address. So if we divide by 8, there is what? 6 BYT byte. So how many byte? There is the 6 byte. So if anyone asks what is the size of MAC address in our PCs or real scenario, we can independently say that there is the 6 byte or 48 bit of the MAC address. So it also clarifies these things. So what is the protocol size? Protocol size means the size of the IP address, 32 bits. 32 bits. If we divide 32 bits by 8, then there is 4. So the answer is 4 byte. So it is also a simple thing. In opcode, and opcode here is, you can see here, it is the request message. This is the ARP request message. So we are reading, this is the what? ARP request message, and the opcode for ARP request is 1. What the opcode for request is 1. So simple, it demonstrates or it shows that the packet is ARP request. And sender MAC address, simple thing, this is the MAC address of PC1. So sender IP address, this is the MAC IP address of PC1. Simple, we configured before. And target MAC address is all 0, that is empty. So there are two PCs in our scenario, PC1 and PC2. So source IP is known, source MAC is also known, and destination IP is also known, but in the destination MAC field there are all zeros. Okay, this is what the ARP request. So while replying back by the PC2, it will put its own MAC address in this destination MAC address field, right? So that the PC1 will get the MAC address of PC2. So this is the real concept. So target IP address is there, and in the target MAC address there is all zeros. So we need to understand there is all FFF and there is all zeros. So this Ethernet field destination MAC address means this is the broadcast packet, and this 000 means it is the ARP request message in which the target MAC address is used to resolve. So this is what the ARP request packet. So this is the most important thing. If you understand this, you can understand anything. So let us take another reply message. So first one is request and second one is reply. So we are going to study about the reply packet, right? Are you getting, guys? Is there any confusion? Please reply.
No, go ahead.
Okay, thank you. So we're going to study about the ARP reply message, okay? So these are the things we need to study, Ethernet and ARP. So let us study for first Ethernet. So in the Ethernet, the destination MAC address is PC1 and PC2. So this MAC address is which MAC address? It is sending back the reply, right? The PC2 is sending the reply to the one, right? So the destination MAC address is obviously the MAC address of PC1. So this is the what? MAC address of what? PC1. So in the request message, there are all Fs, right? There were all Fs in the destination, but in the destination MAC address of ARP reply message, there is the actual MAC address. So we need to understand what the ARP request request message is, what BROD broadcast, and ARP reply reply is what? Unicast, because it has the actual MAC address and it is the unicast. It will only be sent towards the only one device or only one host. So we need to understand this. So there is the actual MAC address of the destination and it is the source MAC address of his PC2. So this is the MAC address of PC2, and this is the hexadecimal value that represents the packet is ARP resolution packet. So the packet inside the Ethernet is ARP. So it clarifies. So this clarifies that. So I would like to make you understand from the OSI reference model. Layer 1 is PHY SICL physical. Layer 2 is data link. Layer 3 is network, right? So it is connected over here like this: physical, data link, and network. So first physical will get the bits 01010, and second it will get the Ethernet terrain, only these things. So it will only study first the data link, not about the layer 3, because it is inside the encapsulator, right? So in the layer 2, how it knows what type of packet it is. This is the ARP packet. So the PC2 knows it is the ARP packet and I have to reply back. So this is the concept, and what is the use of type field is the actual thing that I already said. This is the hexadecimal value that represents the ARP packet. So what are inside the ARP reply packet? So same thing, it is using the Ethernet technology, and protocol type is IP version 4 0/0800. What does 0x means? It means the value after this is the hexadecimal value, right? You can understand the hexadecimal value easily. So what is the hardware size? This is the hardware size, means MAC address size. There is 6 byte, DYT byte, means 6 into 8 is actually called the 48 bits. So MAC address is 48 bits, and protocol size is 4. 4 BYT byte is 4 into 8 is equal to 32. This is the IP address, because protocol size and hardware size. Hardware means MAC address, protocol means IP address. So someone, I think, are waiting for my session, right? Let me admit. So hardware means MAC address and protocol means IP address. So opcode is 2. It means the packet is here is the reply packet of the ARP. So it represents, this is the reply message in the sender MAC address. See, PC1 and PC2, right? So in the sender MAC address, what is the MAC address? In which device the MAC address is it? I would like to ask a question, right? This is the MAC address, right? And this is the ARP request, not ARP reply message. Then please anyone answer me, which device, either PC1 or PC2, the MAC address belongs to? Which device MAC address belongs to this MAC address that I have, this source MAC address? Whose PC1 or PC2? Please anyone answer. Hello?
There's the way back is PC2.
Yeah. You are saying PC2, right? Yes, yes.
Oh, yes.
Sorry,
Yeah.
can you tell me from where the traffic is generated? PC1 or PC2?
The packet was generated in reply back towards the PC2, from the PC2, because we ping from the PC1 and ARP is sent from the PC1 and ARP reply message should be sent from the PC2. So this packet is something like generated from PC2.
Yeah. The ARP response will be from this PC2.
Yeah. And the source MAC address belongs to what? PC2, right?
Yeah.
Yes, thank you. You are correct. And the source MAC address is here. And source IP is the IP address of the PC2 that we have already assigned 1.2, right? And the target is what? The MAC address of PC1, and the target MAC address of target IP address is belongs to the PC1. So from this, the PC1 knows from which MAC address the packet is coming. See, this is the actual MAC address that is required for the PC1. So it will put this MAC address into ARP table so that it resolves the MAC address. Are you clear? If we want to see the MAC address is resolved or not, then we can simply go to the console. So let me check the ARP entities. So ARP, there are two ARP messages or the MAC address that is available in the MAC and not ARP table, right? So this is the ARP table which can be viewed from the simple command show ARP. So just let us take 2-3 minutes over here. So this is the internet, means this is the IP version 4 address, right? Why it is not writing? Oh, it works. So this internet means this is the IP packet or internet protocol address. So internet protocol. Okay. Okay, just 2 minutes, sir. Then after that, I will take the question. Okay. Hello. Oh, thank you, sir. And then this is the what? IP protocol. So this is the IP packet. And what does it mean? As MIN mean? This is the aging time. Aging time means in how many time the IP table will remove all the entities. So this is the age. So it means in how many minutes it will remove. So it means the dash means this is the statistically learned or the manual learned. So it will not remove anyhow the MAC address that is available over here dash. So this is the own MAC address. Can it be removed? The own MAC address? No, never. But there is 16 MIN minute, right? So it means that the MAC address learned over here has becomes the 16 minute left. So the by default, by DEFAULT by default, the ARP table will remove all the dynamically learned MAC address into the 4 hours, 4 HOURS hours. You need to understand this. By default, after 4 hours, all these ARP entities will remove. So the dash means it is the statically or manual configuration. So the 16 or this means this is the dynamically learned MAC address. So it will be removed after 4 hours. If you want to see what is the aging time of the ARP, we can type the simple command show IP INTERFAC interface FH 0/0. Oh, so ARP INTERFAC interface FH 0/0. So I need to see the command. Okay, we can just search COMMND command to see the aging time of ARP. In Cisco conft, we need to go into the configuration mode. Conft, so IP So ARP something like, we can just view the command over internet. Okay, so we can just see there is the 240, 4 hours. By default the 4 hours is the aging time of the ARP table. As in the MAC address table there is something 300 second or what, and in the ARP table by default there is 4 hours of aging time. We can change that aging time with the command. Okay, so let me ask some question. If you have any doubt about this session, so please anyone can put your question. Yes. Yes. Okay. I would like to make something. Yes, sir. Please, can you ask again? I didn't get the question. So, yeah. Yes. 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 Okay. Okay. That is the simple question, right? Because in the networking technology, okay, in the networking technology there are something like the layers, TCP IP model. Okay, so in the TCP IP model there are 4 or 5 layers. In something web browser you can find 4, or something you can find 5, but in the OSI there are 7. So in the layer 2 internet protocol there is in the layer 2, that is data link, right, or link layer. So there has MAC address and there is IP ADD RESS address. So these two fields are the compulsory things to communicate with any devices in the network. So if we have only the IP address, it cannot communicate with each other, but we need both IP address as well as data link MAC address. MAC is required to identify the device. Something like you wanna say that MAC address is globally unique, right? Yes. Okay. 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 Yes. Okay.
So you want, do you want me to explain?
Yeah, I got the answer, right? I got the answer. In
Sir,
the
can I
global,
try? Okay, let Ayush try, then I will.
okay, in the global network, right? The pen is not working. Why? Okay. Okay. Simple. It will make clear. Okay. So I would like to make you understand through the speaking. So in your home network, in your home network, you have the IP address 192.168.1.0/24, right?